before tea break, what we did all these FSL approaches, basic idea, and what this Chinese network quite interesting and very important to know behavior of what the FSL model is all about. So once it is done, also we saw a couple of applications, natural language processing, robotics, acoustic from and other applications as well. And of course, the key issue, what core issue is that in order to reduce the empirical risk minimization, what we have to work on these lines. So the data model and the algorithm. Okay. So these are the hypotheses, like start and edge or something like that. This is what the estimated error, and we have to reduce the estimated error, building this hypothesis in a greater sense. So, and I told you like we can do it in data model and algorithm, use prior knowledge to augment data and increase the samples from I to I dash, where this I dash is greater than, much greater than I. So one way what you can reduce the risk. And model is that, yeah, hypothesis model. So like you have to make this small h cap. So this is what. And lastly, with respect to the algorithm, search strategy, hypothesis based by prior knowledge. Okay. Coming to the case study, actually what next in my practical session probably I will be taking on signature. And here, like to give you a sort of brief idea, like what we did in 2020, and it appeared in Cognitive Computation Springer 2021. This is due to what one-shot clustering based approach for the detection of COVID-19 from chest X-ray images. I told friends that getting these data in early 2020, it was quite a difficult task and quite challenging because with the data was very, very limited. And now these days, so probably you have plenty in Kaggle and GitHub and all. So probably you will get hundreds and thousands of images on COVID-19. So now you have models and many more, something like that. And while doing so, probably what we learned, like there is really need for learning the things with the very limited images. Due to that, what motivated us to come up this idea. And basically what is something like we start with one examples and then we'll try to develop some clusters. This cluster is something like cluster of images are the samples. And we use this cluster. These data are so vibrant, important, and having some sort of very good information compared to the data, images in the database. So probably you use this, and finally what we use for recognition or classification purpose. So you can, this is a publicly available paper. You can just type this and easily download. You can download this paper for your reference. So I just skip this very important task, and everyone knows this, like the deep learning models, which requires huge amount of data, and it requires huge amount of time to get the thing. So probably what our idea initially was something like that. Why can't we develop some machine learning algorithm to solve when the data are very, very limited in nature? So probably when we train very little amount, so probably it helps in the effort. What I told you, the motivation is something like effort is also reduced by collecting, at the same time computation is efficient. So we have to retain, at the same time, we have to retain the accuracy. That's of course, a very, very important point whenever I talk about the machine learning. So the contribution is that we have come up with taking the advantage of what generalized regression neural network and probabilistic neural network. We have done this approach. So we have taken this advantage of this architecture, the generalized regression neural network and probabilistic neural network, and then finally we solve the problem. More or less like this is how it goes. So you can see this diagram. So what we have done is that initially we had 4 classes. These are all 4 different classes. This is what COVID 19 X-ray image. This is normal, regular one, and this is what again normally what in the reports, research reports, we see only the classification of COVID and normal. But also what we tried in seeking with different what pneumonical problems like pneumonia virus and pneumonia bacteria, something like that. So probably we added these two as well. So totally our model is of 4-class problem. And then once we had these images, we have 4-class and we will take only one samples out of it. Every time we take only one sample. And then that is why we tell that as a one-shot learning. So we take only one images in the database. Randomly you can do that one. It's not a problem like you can ask like, do you have any mechanism to what, let's take an example, in each class if you have hundreds of 200 images, so probably do you have any mechanism to pick the best one? So probably initially we don't do that one. Randomly we will pick some random images and finally we will extract some features out of it. Next in the next level, so probably here, so what we will select the best out of the databases. That is what the overall idea of this one-shot cluster-based approach. So we have taken these images and finally we have extracted the raw information. We have not done anything here. So we have not gone through the convolution yet or something like that. We didn't do that one. Simply what we extracted the raw features. Those extracted raw features, what we have given to the regression neural network, generalized regression neural network, and the probabilistic neural network. So what we normally do is that how are you going to perform the best performing samples, the question. So in order to do that, what we'll do is that, let's take an example. We will out of these 4 classes, we will take one, and finally in order to study or in order to understand the behavioral aspect of this class, so probably what we will run with all the samples, keeping this fixed. So this image is fixed in this class, this image is fixed in this class, and finally this image is fixed. But what I do is that, keeping these images in these classes fixed, I run all the images in the database, and finally I will see for which images, so probably picking, so probably I'm getting a good recognition accuracy. That is what we are normally trying to do here. So once it is done, so using this generalized regression and the probabilistic neural network, we will choose the best performing samples. Let's assume that I kept these 3 constant or fixed. Finally, let's assume that out of 100 samples in this database, 45th image or 90th image or 93rd image is performing very well. I mean to say that when I take those images as fixed, so probably if I run for all 100 test images, so probably it is performing very well. I take that one as a ground, nothing but I make as a cluster, and finally I will use those cluster for for my approach for recognition purpose. It's the same wise we will do that we will fix this 2, 3, 4 we will fix, and finally we will perform the suitability or the superiority of this class and this class and this class, and finally we will cluster some very prominent images in the database, and finally we use ensembling approach. Ensembling approach, it is not with respect to the OR operation here, friends. We are working with 2 classifiers, so probably many of the researchers will do the R classification, but we are very stringent. So probably we are working in this medical field, so probably we should be very stringent with respect to the approach. We have used the AND operation. Even the GRNN says yes, so probably we also expect that probabilistic neural network should also say that this is what the right class. So finally we will do some classification, and finally we will end. So anyhow, we will show the practical way by using MATLAB, how exactly we have done with starting from this to this yet. So this is what we database public level GitHub. We have 4 class. We had around 306 images, which is break down to 69, 79, 79, and 79 respectively from each of the 4 classes. And this is what initially we do. We initially, as I mentioned this one, this you can see the distributions here. See here, we have GRNN, normal GRN, COVID PNN, and normal PNN. So probably you can see, let's take an example. You can see the distribution, whichever is giving the best result. So probably in this case, like this image number 16 is performing very well. You can see the ups and down. So probably there are images like 51 and 50, which is not at all contributing for the success of the story. So probably whichever having the highest recognition accuracy, so probably I can pick it and for my next processor. So this is what one way of what giving some idea like why and how what we going to what initialize the operation. So this is with respect to 4 different classes. This is for 2 classes and this is for 4 classes. Cluster and ensemble we do and our approach, and we have compared with the existing AlexNet, GoogleNet and ResNet. Of course, our approach is performing very well. For 2-class problem, we don't have any problem. We are getting 100% results. Of course, normal also, yes. The overall average is 74 when compared to other with the proposed one. For the 4-class, it is 72%. So quite interesting, but anyhow, still we have a room to what improve when the class sizes and other things goes off. Okay, so we'll go directly to this algorithm part. So I will show you the database. The database is what. Yeah, I have considered the 3-class problem. This is what the signature of the people. So I have taken 50 samples. Normally, what usually we don't get these numbers. I told in the earlier, but only 10 or 5 or something like that. But our approach is entirely different. I am telling you again. We are not really not what oriented like OSL or FSL approach where we have a support set or something like that. But our initial what idea is something like that. Extracting only one image and finally understanding that one, how I can make a cluster, and finally how I can develop a model, that is entirely different. So probably the idea with respect to FSL or OSL with our approach is entirely different. So probably we are showing that we are recommending saying that, so probably we also what we can work on these lines, so probably what get some good results. So that is what the overall idea of this problem. So this is what we have 50 samples. You can see the images. People have written in many ways. Okay, and this is what the class number 2 is 3. So these are the signatures pertaining to the class number 3, and we have some class number 2. Fine. So yeah, so this is what randomly I have picked one image from each class. I have taken this one, and this one. Initially, what I keep this as for my initial phase, and then what I will evolve the cluster. So we'll see that how exactly I have done. So first thing, as I mentioned, this is what the source database. I think many of you know the MATLAB. So how many know MATLAB here? Aware of MATLAB? How many aware of MATLAB? Are you people aware of MATLAB? So otherwise I have to go in detail.
Yes, sir.
Yeah, you are aware. So probably it's okay. Only the result is what interesting here. But anyhow, the language or the platform doesn't make any sense. But only the algorithm model we have to learn. That's it. So this is what the source where, as I mentioned, I am testing with respect to the class 3 here. And this is what the one-shot folder where I have only 111 of 3. So I'm just running from 1 to 50. The total number of what characters in my database is 50 here. So NOC is 50 here. And then what I did, so I have to take each one and then I have to put it into my features. So I extracted the first character in my source. The source is one shot here. So I just read that. I'm checking whether this is what color or something like that. If it is so, probably what I'm converting to gray and just reducing the size. See, of course, this plays a very important role here. Dimension, like varying the dimension, like 50 to 100, 25 to 50, or making square or something like that. Of course, a challenging here. As and when you do some sort of pre-processing here, change some character size to 100 to 100 or 50 to 100. So probably the results also varies. And finally, what I'm doing is that I'm extracting the one dimension of that 2D to one dimension. So probably I can use this MATLAB code, and finally I'm putting into a variable called TRFM and placing at the first position. So I'm extracting the second one. That second one is this is first one, and this is what the second one is, Radhika here in this example. And what I'm doing the same here. I'm checking for the color and then converting to gray if it is so, and then making the size as uniform here. I have fixed is 50 to 100, and then I'm just putting into the second place. So the third one, now what I'm trying to do is that I'm just trying to figure out this database. I'm trying to find which of these images are good when I keep these two as a constant. When I keep these two as a constant, so probably I want to see what samples are really performing well to my success story. So in that way, what I'm trying to do is that I'm just extracting with this source C3 here, source 1. And then every time I pick one, and then again I will check the data, the database full. I will check the database, and finally I will see how many of it is giving the best result. So let's take an example. If it is picks 1, so probably all other 49 I will test. Again, let's take an example. When I take 2, I will just skip this 2, and finally other, like leave an out strategy, something like that. So 1, 3, 4 other I'm going to test, and finally I will see what is the result with respect to when I keep these 2 as a train and then 3 as a train, something like that. Okay. So coming to the, this is what the first part, and finally everyone knows about this one. This is of course a supervised way of learning approach. So I'm giving the target 1, 2, 3. I'm labeling the database as 1, 2, 3. So this is what 1, 2, 3, the first class, second class, and third class. I'm doing some stuffs here, doubling, converting into double. And these I will tell you little bit later at the end, because very interesting. Many of the people who really work on neural networks should be very careful with respect to normalizing the data. Of course, if you don't do the if you don't do that, so probably your accuracy also varies. So if you do that with respect to normalizing, so probably you may achieve something interesting result. So anyhow, I will tell this later at this line number 74. And then what you call the generalized regression neural network, which is readily available in the MATLAB, and you can see what it does. So this is what the different architecture that is available in the neural network, generalized regression neural network. So you can see how exactly it works, and all other stuff, information you can just take with this function, and then you can see. I will not take much time here to explain, but only thing I'm just giving an idea of exactly what we are doing. So what is the input for this? We have to input the features. That this feature here, the feature is simply a gray level intensity. That is nothing. We are not really extracting any other information. We are just extracting the raw data, and finally the target, associated target for each sample, and then I will build my network. Once it is done, what you call this guy here, the class number 3 guy. So where you have 50 samples. So now let's assume that I fix this class 3. I fix this image, and rest all other 49 I'm going to test it. Let me see how exactly I'm going to get the result. So in order to do that, this is what the code. So I'm just taking from this class 3 all in JPEG format, and now what I'm doing is that I will do the same here. Whatever the thing I did here, if it is in a color, so probably I will be converting into a gray. I will be converting into gray here, and then reducing the dimension to 50 plus 100, and then whatever I get, so probably I will just keep it here, and then I will do it for all 49 or 50, something like that. Once it is done, what you call the similarity net. This is for classification, prediction. Normally, we call it as a prediction one. So you give all the images, test images, and finally see how many classified into, how many classified correctly. So this is Y2 gives you the numbers. So anyhow, I know that I'm giving the class number 3 as an information saying that the test cases are coming from class number 3. I want to know how many are into class number 3. So finally, I'm just calculating the accuracy, right? So I'm just clearing this for my other purposes. So finally, I can run this one. So yeah, you can see here the numbers are changing here. Yeah. So here from starting, I can show you. See here. So for the count number 1, like when I fixed this as an image and rest 49 as a testing sample, so probably the result I'm getting is 14% accuracy. Likewise, you go down. I did choose these 2. It's really very bad. It is not performing that much well, and finally it is leaving to only 2% recognition accuracy. And when I take the third one as a sample, so probably I'm getting a good result. Of course, 46% mean to say that 25 to 24 samples are saying yes, it is. Be careful here. I just tried only 1 images and I tested 50. So you can see the result. It is almost all 50 to 60%. I'm getting good results. And then likewise, the 4th character, it is saying 42. The 5th is 10. Yeah, this is very interesting. The 6th one is saying 68. Which is the 6th one? Yeah, this one. So this image, so probably what I can use for my next level processing, saying that this is quite interesting. This is, of course, it is something like in a class of 60. So probably you want to choose a very bright student or something like that. In order to pick that bright student, so probably what you do. So we will do exams or many other stuffs, and finally we'll pick it. This is what the overall idea of cluster does it. So this one I will just pick for my next purposes, and the second, this is of course 9 and 6, 52. You can keep some threshold above 50, above 60, or something like that, and then you can make 1 or 2 databases. Right, 5 and 6 is good. 44 is okay. Anything that is, this is 52. 19th image, I will just check it out. 6, 9, and 19. I don't know. Rest I have. Okay. 35, 36. In that range, I'm getting. Okay. 45. 58 is also good. 48. Yeah, I can take this one. Okay. So finally, what I do is that I take all these and then I will make as a folder saying that cluster. Okay, so this is what my cluster image of class number 3. So likewise, you have to do for class number 2 and 1. Let's assume that I do for 2. Quickly, I do change the database 2. And then what you have to do is that you have to keep varying this one. Stuff. Okay. So,
sir, one doubt.
Yes.
Is any reason why these 4 are best classifying the set of rest of the images? Have you find out the reason? or because are they close to the average? So what is the reason
Yeah,
behind?
that is what we did, right? We ran the algorithm here. We ran the generalized regression neural network and the probabilistic neural network. Based on the decision, what I'm getting with respect to the here in this case, I'm just running only one architecture. That is the generalized regression neural network. And find it. So probably I'm finding out based on this. So probably these are the images, set of images, which really what performs well in my during the testing purpose.
Yes, sir. But
Yeah.
why? The reason why, like maybe if we take average of all the images, these are closer. Some intuition, why these are best, why not others? Because almost all are same. So any logical inference able to are you able to
No,
deduce?
no, not logical. See, what we are trying to do is that we are extracting some information. So probably the other what information, what the images we have. Let's take an example of here. We come to that point. That is what the normal what machine learning works, right? So let's take an example of these samples. So you can see there are a couple of what images which is really what not to the matching purpose. So probably when I take these one and finally what I will test with respect to the one-to-one, nothing but I told you in the beginning of my session, like you are comparing with what you are comparing with one-to-one, nothing but similarity or something like that. So same thing like you have extracted the information and finally when I create the network, so probably these images is not matching with the what my sample set. Are you getting?
Yes, sir. Also, if we change the classifiers, I
Yeah.
think
That is what that story is different, entirely different. I will come to that. See, this is what initial step in what designing and doing. Here, what I did, what I did in a very different way, and you can ask me like, why you took only one. You randomly, I said, right. I consider only one. Why not? If I take this one, so probably my result will vary. You have all those trial and error methods, so probably you have to do it lot. Are you getting?
yes, sir.
So
So
lot of challenges are there at the same time. Extensive experiment you have to do altogether. Like initially, I randomly choose one something like that. What is the cost? Something like that. If I choose some other what character, and also very interestingly, I just checked with one this one like one shot like one and finally I just trained this one. What happens if I choose some other one here and finally if I vary this one altogether I have to do 50 into it's something like a permutation combination problem.
sure, sir.
Yeah, so a lot more challenges. All depends upon the classifier. Let's take an example. If I apply what probabilistic neural network for this one, so probably it varies. It may not give the same result as it is, and finally it may suggest saying that whatever the clusters you have made, so probably it is may near or may not. So of course that is what the overall problem with the existing or something like that. So that is why like hybrid approaches, many other stuff comes into picture. But altogether, what I can say is that let's take an example. If you are getting 80%, so probably if you use other model, so probably you may get some increase or may decrease with plus or minus 5 or something like that. Okay. So those problems are there, and finally, what all other trial and error method we have obviously we have to do, saying that okay, these are the best what images. So probably in the database, if you want to pick it, so you have to justify saying that yeah, this is the reason. We told what we recommend normally is that if you do in this way, so probably I'm able to what cluster some of the best images rather than simply what training all. What I did here, I did at the next point. What I do is that I simply train only these images. Let's take an example again. Like I have another one. Yeah, train here. Yeah, yesterday I did this one. So finally I took this what clusters, saying that I told 7, 8, 9 from this class 3 and this is from class 2 and this is class 3 and I made a cluster here and finally I used this cluster for my training and finally to test for other 50 or 100 images. So this is what my overall success story. This is what the clustering is all about. So probably I choose the best images out of these databases and these best images are something like a support set or something like that. I can call it like that and finally able to what classify using only this set for my recognition purpose. Is that clear?
Yes, sir.
Okay. So yeah, likewise we have to do for the second, third, and all. But anyhow, I will not run all those things because I have to what modify here. Modification is not a big deal, but only thing is that it requires a bit of time here. What I have to do is that when I want to do with the second one C2, so probably I have to change here the character paths. I have to what remove this for loop, and then same rest remains the same, but I have to what take this guy here and I want to put somewhere here and make it 3 2. So I have to the second class should fall in the second line in the my training. That is what the thing I have to do, and the rest use the for loop for running from I is equal to 3 to 3, and then end it. So and then we remove this guy. So now what happens? So this it will take the first one, and from the second what you have to change the source. Source one you have to what tell. The source one is this one, and you are taking from the second class database, and you place it in the second and third one, and all other remains the same. And now here what you have to test the second one. I'll show you how exactly we're going to do that. And now you check it whether it matches with the second, and so on. So now we will run this. What happens? Okay. So I can go line by line. Okay. So this should be I1. So this is I. Okay. So I1. Wait a bit. Yeah, this should be I1. Sorry. Okay. Oh my. Yes. Yeah. It's fine. So we take this as C3. C3. Yeah. So problem. Sorry. Let's look. So finally, I got it. So this is what the first and second one the same. Like you have to change this one. You change this. Then I take the second one. Then you place that I want to. Do it for now. This is for the second one. Change this to. Let me see. This one 3/5. But anyhow, to also. Yes. This. Okay. Well, oh, but some results are not satisfactory yet. Actually, I think we have some problem here. But anyhow, this is what we have to do for the second case. So you take the second in the database, and then you keep one in the image, and then the source image. You have to change it. So this is what the source. Source of file. We have to do a lot more other things. But anyhow. Yeah, now, oh, something. Okay. But anyhow, this is what the overall idea, but nothing to worry here. So the class, when you take the class 2, so probably what we have to change here, we have to change from the source, and finally you pick the numbers. Okay, then what you fix the class number 3, and then once it is done, anyhow you know this one, what made 1, 2, 3 as the test case, and then you run the regression, and the class number 2 you run, and you see the result whether it is getting the good result or not. So now let's take an example. I made something, and finally this is what my clusters. So I just label it 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I can run my on cluster image. So once it is done, so let's take an example. This is what I done. So 1 to 9 I have. You just take it, and then you label it 1, 1, 1, 2, 2, 2, 3, 3, 3, and then you try to see what is the result we are getting for class number 3. So finally, this is what the OR operation I'm doing. So probably you can also do for the AND operation. Okay. So just run this. Let me see what the result I get. Okay, so I'm getting 26. So this is what the percentage out of 50 when I tested, I'm getting 26. So another very interesting is that uh, I told you very clearly this normalization. So when the feature dimension is huge and you have a big number, so probably what you can change this into some normalization factors, like 4 zeros you divide or 4,000 four zeros you just multiply. You do like addition, what multiplication or division, something like that. But anyhow, this is what sort of trial and error normally what we have to do when you use neural network. So probably these changes. The 26 of course it's not changing. So I now I will try to see the class number 1. What's the result it is getting? For class number 1, then you have to change this one. So you see what's the result. So I think, yeah, it's 100%. So class number 1. So I just tested this one, all 50, and finally it's telling that you have an 100% result. So that tells you that the clusters, what you have done here, this set, so probably these are sufficient and giving sort of justice to your learning part. Okay. And then likewise, you can do it for the second and third one. You can see here the result may also vary if I just bring it to some one. Yeah, this time it's giving good, not a problem. Test this second. Yeah, it is 72%. So class number 1 is 100%, 2 is the 72, and last one is the 26. And on average, so probably is 198 divided by 3. The average is 66%. But actually, this one, the train I have not taken from actual the results. So simply randomly I selected to show as an experiment and I'm doing. So probably whatever I have here, here in cluster. So probably this may what result in a good performance. Let's take these two and then I will just let me try. I put it here. Okay, so I just changed the images. Now let me see how it. Let me train and see the third one. Third one was getting 26. Earlier, let me see what it is. Yes, see, 26. Where is 50 and 26? So 100 plus 72 plus 50. 2 divided by 3, 74. Earlier it was 66% of accuracy and 74. So this is what the key idea with respect to word clustering. When I did change with respect to what the good performing images that I got with respect to the initial one. So probably my what accuracy is quite improved. And I can say that these are the best images what just justify or just tell you about the database. So keep these and finally you keep as a training set or a support set for your classification and then you can do a lot more things. Any other questions regarding this? Happy to answer.
Sir, but to adapt this technique, we need to have more samples now, sir. Like it doesn't work with if you have five samples per class. I think this technique.
No. That is what I'm telling. This works with very limited. Only we use only this training, right? Here, what I did, I trained only this one. This is my final this thing.
Yes, sir. But to come to this training, we have used 50 samples. So out of
No,
50,
no, 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 no. So don't confuse with that one. See, initially what I did, I took only one, and that is nothing but a pre-processing part. Arriving till here, it's nothing but a pre-processing, I say. Why? Like I'm trying to understand the behavior of each sample in the database, and finally out of, let's assume that you have 50,000 samples given, and finally in order to what train, that is different story. You told, I got your point, like saying that you are even the effort of computation is also there. So probably yes, I can understand, but once it is done, this is only one time I do. But afterwards, so probably I get a handful or a meaningful images. So probably I can keep in a database, and finally I can utilize whenever I need.
sure, sir.
Yeah. So of course, this is entirely different compared to the previous one. Like the FSL. FSL, what it does, they train entirely different one, and finally support set they will keep, and finally they will do the task. Nothing but similarity. What we are trying to do is that we have trained, of course, the known one. But why I trained is that I want to know the how best each what image gives to my success story. That is what the main key idea about this algorithm. And finally, I handpicked very few. You believe it or not, in this paper where I mentioned, yeah, we can see only two. This is what the two class, and the number of samples I have used in the cluster one is only 5 samples. 2 from class 1 and 3 from class 2. So out of finally I have tested with all other samples, and finally I'm getting what 100% recognition. Okay. So here see the cluster 2. The cluster 2 is 7 samples, and when I take the class 3 results, so probably you can see here. So the what it is giving 85 or 79% of accuracy. So this is one way of what representing what the overall idea with respect to the machine learning. So probably we recommended like saying that this is the way we can also work and finally do some classification and the regression problem. Okay. So as you mentioned, there are other things like of course it's a lot of trial and error processing. I just randomly took one and then I checked it. I don't know what happens if I change the algorithm, as you mentioned. If I change with respect to the the image size. Very interesting is this one. So people who use what probabilistic neural network or the generalized regression neural network. So probably you should be aware with respect to this feature set. So probably when the feature set is too big, like the elements of the features is like, let's take an example, 1000 or 2000, it is representing in that number. So probably what we have to reduce this into some standard, and then you have to, once you reduce it, so probably there is a chance of getting good result as well, right? Any other thing? Questions? Clarifications, please, regarding this case study. So fine. Now let's move on to this one. We'll continue with this. So I was talking about the clustering and ensemble steps and all. Now these are the observation what we finally penned it. So the concept of one-shot learning based is being first of its kind. And of course, we have written very clearly that it expected to open several dimensions in the field of machine learning, which require further researches for various applications. So of course, we are tested only for this one. So I don't know how it works for signature or any other forensic application where we have only, of course, limited data. And initially, whatever I did, so probably I cannot do that one. So probably of the limited data. But anyhow, really what challenges do exist. And the future direction is what the, with respect to the 4 verticals, one is problem setups, techniques, applications, and theories. So problem setups like existing few short learning methods often uses prior knowledge from single modality, like such as images, text, or videos. So probably what there is always a scope to work on multiple multimodal modalities. Like this is an example with respect to the study of extinct animals. While these animal species may not have a limited number of visual examples, so probably you have some other textual domain, like a lot of information available in textual domain. Use this idea, use this plot, clear knowledge to solve your problems. So in future, a promising direction could be something like multimodality information. That is what I said. Like when someone told me about when asked about the semi-supervised, where with respect to the semi-supervised, we have very limited of supervised in nature, and rest everything is unsupervised. We don't know. Like so, probably in that case, given an image or a given sample, so probably how it matches with the known or to unknown is of course a challenging one. Of course, I did tell that one. So if you really model in such a way that so probably we can, if you use like multi-model or modality, something like that, so probably we can do some task. Only thing for the semi-supervised is that if you induct the idea of prior knowledge somewhere in your model, so probably you can solve the problem of semi-supervised in a better way. So that is what I can say to the participant who asked regarding the semi-supervised learning. So the techniques, OSL and FSL methods can be was categorized into perspective of data, model, and algorithm. And of course, these components can be improved. You have a lot of room in improving with respect to data, with respect to the model, or it could be in algorithm as well. So what is meta learning is all about? Is of course it's all based with respect to the first few shot learning, which is of course a key point or the key factor in learning things. So coming to the applications, I just gave in the previous slides, like wherein all you can see the application. Computer vision is one of the very first test bed of OSL or FSL problems. Recent attention, we have seen a couple of things on robotics, natural language processing, and acoustic signal processing. Computer vision, like character and image classification, two most popular applications. So OSL or FSL has also been successfully used in video applications, including motion prediction, video classification, action location, person re-identification, detection, and object segmentation. And there are a couple of things with respect to the robotics, natural language processing, acoustic signal processing, and others like medical dress design. So these are the applications where what is all based on the approaches of OSL or FSL. So yeah, this uses the So finally, what convergence of FSL algorithm is not fully understood. So the more general analysis of convergence of meta-learning methods will be highly useful. And small number of methods have been studied so far. There is still a lot of theoretical issues to explore. I told in the beginning of my slide that, of course, this is very not a mature one like a traditional machine learning approach. This is totally immature. So you hardly we will see some of the couple of papers. So probably like Siamese network, triplet laws, or many other things. But people are now working on this line. Of course, in future, probably after down the line 5 years or so, probably like I do hope that really lot of research will really go on this OSL or FSL, because like every time we have a set of problems. Of course, the dynamic in nature. Every time we will not get the same thing, so that problems will get changed. So probably we have to adopt the technologies or the methods. So probably in that way, these OSL or FSL probably down the line 5 years, so will be going in and will take in a different directions. So what is the challenges? Very important slide to conclude. Like one-shot learning algorithm is still relatively immature. Of course, a few shot, very hardly we will see some papers. Poor performance is also there. Like there are cases like, even let's take an example with respect to the criminal investigation or something like that. In the database, you would be having very images of highly disturbed or perturbed. Like you are not able to see the face properly. You have a lot of noise or something like that. given such instances, so probably whichever the algorithm is very, very hard to perform. So these are, of course, performance maybe with respect to this category. And also, like I told, like there are many other things in order to what improve this performance. So probably like you can work on data, something like pre-processing with data augmentation, try to enhance your image or whatever. So probably, or otherwise, if you want update the thing with respect to the model or algorithm, of course, there is a room for the improvement. And fine tuning on one-shot learning is likely to severe overkill. So this is where normally also usually applies in the traditional machine learning. So whenever, like, as the number of classes increases, again what you want to change the parameters, again there may be a sort of overfitting or something like that. As the size of the features increases, again you will be having some problem. So likewise, so probably what fine tuning the thing with respect to the one-shot learning, obviously what there will be sort of overfitting. So these are the real challenges that do exist in this field. So people are now working on this, like taking application with respect to face recognition, character recognitions, or many other things. So probably like in coming days, we will see like how this gives a lot of scope to solve these challenges. So these are the references you can take. These first papers are probably very interesting. One-shot learning on object categories. After 2006, most of the work had been started from 2016. There was a very big gap between 2006 to 2016, and our paper and generalizing a few samples. This is very, very interesting, very good paper. Few-shot learning in 2020. So all these are with 2015, 18, something like that. This tells you how field is growing now, and people are now working on many other. So this is one-shot digit classification based on human concept learning, our own paper, which is accepted in one of the international conferences. Okay, thank you very much. If you have any doubts, clarifications, please, you are welcome.
Sir, I have one doubt.
Yes, sir.
In the morning lecture,
Yeah.
sir, if you have the slide, sir.
Yeah, we'll share this slide, no doubt.
No, sir. If you have that slide, if you open,
Yeah, okay.
a bit confusion.
Okay.
In the morning lecture about one-shot learning.
Yeah.
Yes, sir.
Yeah.
Yes. Go back, sir. Please. In the subset, go back, sir.
Okay.
In the subset example for M-nest.
Subset? Yeah.
So here, sorry, sir, support set. In the support set, this 6, 7, 8, 9 or doesn't belongs to the training set.
Yes.
And if you go to next slide, in the next support set, support set here, sir. Here support set, they are matching to the training set.
No. See here, support set actually support set is something like, it's nothing but sort of prior knowledge here. So here what normally we do is that we train which is of unknown. We don't know. Test samples is not seen before. So simply randomly we will try something different. Let's take an example in this case of 0 to 9. So probably what I do is that 0 to 5 I train. The training samples, of course, in this set is huge, maybe huge. And I will tell the system saying that these are the similar objects, and these are the dissimilar objects, and these are the dissimilar objects. In many other ways, what I will train a system saying that these are dissimilar or these are dissimilar. And when coming to the test set, whenever I throw the test set, so probably I use support set what belongs to the class. So you can see here, the support set, it is belong to the class. So probably in the other way, so probably I can also give 0, 1, 2, and 9. It can also take in that way as well. Right? Are you getting?
Yes, sir.
So for the example, I have taken 6, 7, 8. So probably even if you give in this way, so probably once the algorithm is run very well and learned very well, so probably it can classify this 9 and 6. Of course, it can say it is not similar. And 9 to 7, of course, it tells it's not similar. And of course, this is different. And so probably when it comes here, it can say that, okay, this is what what similar it's all about. Let's take an example. If I give you the same thing like 0, 1, 2, so probably able to tell that okay, it is not what it is different, because you already made here. You are told saying that okay, these are similar, these are unsimilar, what is similar or something like that. So probably that knowledge what here I'm encapsulating and finally what telling. So probably using a support. Is that clear?
Yes, so in the next slide.
Okay. So this is what KY and support set. So support set one side said this is what this direct 4 and 1 shot. Of course, this I can also what increase this one. I can make 3 shot, 5 shot, like 10 shot or something like that. I can increase my shots, right? And I can, so probably at the same time I can also what go with respect to the different what ways, like this is nothing but the classes, and for each classes you have different number of samples. I will show you one good paper here. You can refer this one for if you have any. See, this is what Chinese neural network for one shot image recognition. So they have what done on what OmniGlot database. What is OmniGlot database? This OmniGlot database have 50 different what alphabets from different. So you can see the size of these. I just. Yeah. You can see the size of the what OmniGlot database. So the OmniGlot database is of what this many size and all they have done. Yeah, 30,000, 90,000, 1,500 different samples they have used, random with same or different pace. Many things. See here, 30,000 they train, and 90,000 training, 150,000 training, and so probably while learning, what they do is that they give with totally unknown class. So that is what this paper tells you all about. So I suggest you to what really look into this paper. So probably you get an idea how exactly it does. But overall, like this is what like the few shot learning or the one shot learning works. So you try totally the different one, and so probably in your support set you give very few limited one and try to tell like finally while in verification you will be dealing only with these two, and these two, not with this, because you calculate the loss function, you did converge your algorithm with many good ways, and finally what during the testing phase, so probably what will be handling only with this support set and the test case. Is that clear?
Yes, sir.
Yeah.
Thank
So
you.
also what I have wait. Materials I have, like yeah, you can refer these papers. One they've done on face recognition somewhere. Yeah. Anyhow, I can share you. Just send me your test mail, so probably I can share all these materials.
Sure,
for your further reference.
Thanks, sir. Thanks for nice presentation. It is very informative.
Yeah, see, this of course really challenging for me. Like this is of course a new for me. Last year I started, and it entirely took in a different way. That one-shot learning. I started in somewhere away, and finally I ended in something. So probably, of course, I got a very good that paper is really what going well. You can see here. So it's already taking. What 1,200, more than 1,294 access. Some comments are getting from this paper as well. 20 people have cited on there. So this is what the way we did. But really, what now after what thoroughly understanding this in a other direction. So probably I do understand that lot more things we can do using this one-shot learning or a full-shot learning. Okay. I do suggest that there are a couple of what interesting videos, lectures available in the YouTube. Of course, in Andrew Nag also what shared a couple of what interesting slide. I suggest you people to what really look into those videos. Rest, so probably from the resource materials papers, probably what we can take. Any other?
Thank you.
Yeah. Any other questions, please? Happy to answer.
Sir, one participant is asking your material also. If you
Yeah,
share,
yeah, we
I'll,
will share. Yeah, I will share it. No problem. I will send it to what the coordinator. So from the coordinator can take and help the participant.
any questions?
Any other questions, please? If not problem, you can always reach me through this email ID, aradhya@sjc.ac.in. Also,
Yeah,
what
we
you can take my number if you want, and you can even get that. So, future collaboration also what I do expect. People really interested in working on this line, so probably please reach me out. So we can work on, of course, a lot of real research chances are there, scopes are there. Traditional machine learning, most of the application is saturated. I'm telling you straight away. If you take whichever the field like biometrics, you take in different trades in biometrics like phase or something like that, people are achieving really good results. So probably like when you take with respect to the limited data, when you have a handful of what only few set of images, so probably these are the way approaches what we have to work. Okay. So if not, what I thank all the participants, and also I once again thank the coordinator, Dr. Richa Chanama, for the opportunity. Thank you very much, ma'am. You gave me 2 sessions. One I did cover with on the theoretical aspect, and couple of case studies, and finally the last one, this session meant only for. I thought that many of you people know MATLAB, that's why I just picked out. So otherwise, could have done with. Python, I am not that expert. I'm telling you frank. Frankly, that I'm bit aware with respect to the MATLAB and all, because we do studies on this platform. But anyhow, if you really want require that code, I'm happy to share. You can just write me. I can share my code, all the other stuffs like materials and all. Thank you very much once again. Thank you.
Actually, we should be thankful to you, sir.
I don't know, like I don't know how many people really what it got reached.
See,
So I don't know, like, but anyhow, this is sort of what experiment for me as well. Like a bit, I had an idea, and then I wanted to what every time I wanted to what share the new things. I don't want to repeat the same old stories saying that PCA, that, this, and all. Rather than I'm interested to what explore new things to the research community, because these are the fields like where people I can understand that whenever I go to different platforms for presentation and all, and DAC committees and all, people take the same old paper, what problems, and try to what improve. I don't know where there is a scope for improvement or something like that. But only thing is that real issues is very, very important. And working on this line, especially people are want to work with this machine learning. So probably these are the promising areas for next couple of years.
But it is very informative, sir. Actually, selecting one, how to select, if I have suppose n samples, how to select one out of n.
Yes.
The approach which you have followed is very informative. Based on that, we can do experiment and come up.
Yeah, yeah. Always we have a scope. That is why I'm telling. So, mean to say that I have done only 0.1% of the what knowledge what I have. So probably in many ways you can do, and finally what you can extend the work. So probably you will get in a different. The results are be always in a different way. No doubt.
Thank you, sir. Thank you.
Yeah, actually, definitely what he told is correct. Today's presentation, we felt like it is not a regular presentation, it is like a research work demonstration. As we know that any research work we take, it contains 6 steps. One is first we have to find the problem identification, second is idea generation, and then conceptualize the idea, and then implementation, and then analysis of the results, and then demonstration. Usually any researcher will get stuck in the implementation, so he will have a state of the art survey knowledge, and he will get the idea and he will conceptualize, but implementation is all together, it is a different area, because it needs programming language knowledge, and he has to choose or select one of the programming language. He has to has that knowledge also. So development is a bit part for any researcher. As I told yesterday or day before yesterday, so searching for digital evidence in real world, it's not meaningful, it's not sensible. So as I told you in Anil sir's presentation, physical characteristics, biometric traits, we will not get any evidence in case of digital forensics. So for digital forensics, for digital evidence, we have to search in the digital world only how a person behaves in digital world. So his behavior analysis, I told that we can create a profile of his digital behavior, I mean social behavior in digital world. So that is like an idea, but how to conceptualize, how to get that idea, how to create the profile, so that is another part. Okay, after coming to this, we have come to some kind of solution, but after that, what is there? That is the implementation. So implementation part is very difficult for any researcher, but we have seen that in today's presentation. So he has understood a very bit of implementation and the programming language expertise. So this is a kind of intellectual thing where combination of both the implementation and the conceptualization. So it was very informative, sir. Of course, it may reach to a specific group of people, but still we will learn. We have to learn from that.
Thank you very much.
Thank you very much for the minute details of new idea, and thank you for accepting my invitation and for 2 sessions, so that we got
actually I told I should thank you, because I don't want to rely only on the theoretical aspect. I want to share some of the knowledge with respect to practicals are very, very important. So yes, probably on these practicals, so probably
takes a lot of time actually.
Practical, once the participants get some idea like how exactly people
is also do. Very different.
So probably
that documentation.
And that helps one or the other way for the participants. That's the only way why I did ask you for 2 sessions. Anyhow, thank you very much. Thank you all for the patience listening and interacting. Many participants really do interact with me, so I'm really happy with that. So once again, thank you.
Sir, thank you, sir. Sir, I have added one thing. Sir,
yes, sir.
Sometimes now many problems are around us, but we stuck in the data set, how we collect the data set. So this concept really helps in that.
Yes. So reducing, I do really understand that when we talk about face recognition or any other character recognition, we have to run into many people to capture data or many other stuff. So probably these ideas, like you have only one samples for that. So probably how can really help in taking the step forward. Of course, a challenging work. This learning mechanism really helps a lot in many stuffs.
Yes, sir. Thanks. Sir.
Yeah, I do understand that.
Thank you very much, sir.
Thank you.
Thank you.